This video is about percent yield. Now we're going to assume that as we run the reaction, we spill some product. And the actual amount of product made in a chemical reaction then with normal errors like spilling or having small amounts of product remain on the sides of beakers, having loss along the way, it's stuck on a filter paper, it's on the side of your beaker, it's left as droplets inside of a flask. Usually we can't recover all of it. And so then the actual amount of product made in the reaction is called our actual yield. In other words, we don't end up making all of the product that we hoped to in theory. So we can determine the efficiency, like how good are we at doing this reaction, by calculating what's called a percent yield. Okay, so a percent yield is the actual yield divided by the theoretical yield. So it's a ratio. In other words, how much did you actually make as compared to what you should have made in theory times 100%. Okay, percent yields, actual over theoretical times 100%. So that theoretical yield is often from our Stoich calculations, from doing that mathematical calculation. Let's just put Stoich math. So let's see what that looks like. This first example problem says when 11.5 grams of carbon are allowed to react with excess Cu2O, so this would be copper 1 oxide in the reaction below, 87.4 grams of copper are obtained. Find the theoretical yield and the percent yield. Okay, so we're first finding the theoretical yield, just like we've done before with mass-to-mass calculations. And then we can use that answer to do a percent yield calculation. So this is really mass-to-mass stoichiometry plus a percent yield calculation. So let's get to it. It says that we have excess copper 2 oxide. And it says that we're going to start with 11.5 grams of copper. So let's see from our 11.5 grams of carbon, rather. C for carbon. From our 11.5 grams of carbon, how much of that copper 1 oxide can we make? Okay, so we first do a molar mass calculation. We bring down grams of carbon and we want to get to moles of carbon. And we look at our table and we find on our table for every 1 mole of carbon, there's 12.01 grams in a mole. That's its molar mass. So we've done the molar mass portion. Now we do the coefficients portion. We bring down moles of carbon and we're going to look at the coefficients of the balanced equation and how that compares to the desired product that we're trying to make. It says we made 87.4 grams of copper. We're going to compare. So we want to get to copper. So we're saying for every 1 carbon that goes into the reaction, 2 moles of copper come out. So we did molar mass, coefficients. Lastly, we're going to have to do a molar mass calculation where we get moles of copper into grams of copper. So we're going to check our table. Ours says the molar mass of copper is 63.55 grams are in every 1 mole. So we'll cross out moles of copper and we'll be left with grams of copper. And then we just have to do the math in our calculator. 11.5 times 2 times 63.55. And then in the denominator, we just have 12.01. We'll do all that in our calculator and we'll get 122 grams of copper. That's our units. And that is our theoretical yield. That's how much we should have made in theory if all of our 11.5 grams of carbon to start off, if all of them had made copper, we would have made this much in theory. But the reality is that we actually only made 87.4 grams of copper. So we're going to do our percent yield equation. In our percent yield, needs an L in there. We're going to have our actual yield over our theoretical yield times 100%. So we actually only got 87.4 grams of carbon, or excuse me, grams of copper. And then, so that was our actual yield. And then in theory, from the stoichiometry, we calculated that 102 grams should have been formed in theory. Multiply by 100 just to convert this from a decimal to percent form. So then our final percent yield is, we can put that in our calculator, 87.4 divided by 122 times 100%. We should get a percent yield of 71.7%. So that would be our final percent yield for this equation. Okay, well, let's try another one. This practice problem says how many grams of nitrogen can be made from 9.05 grams of ammonia NH3 reacting with excess copper 2 oxide. Okay, so we have all the copper oxide we need. We're going to be limited by our ammonia, our NH3. Okay, so we have this limiting amount, 9.05 grams of NH3. So we need to start with that. Okay, 9.05 grams. NH3 is my known. I'm going to put it over 1. I'm going to bring down the unit, gram NH3. And I want to get to moles of NH3. My first step is going to be to use molar mass to convert those grams into moles. I should find the molar mass of NH3. I'm just going to have 1 nitrogen times 14.01 from our table and 3 hydrogens times 1.008 from our table. And I just need to add those up. So when I add those up, I should get 17.03 grams per mole for NH3. So in every 1 mole of NH3, there's 17.03 grams because I just calculated the molar mass. So first step, molar mass, then we'll do coefficients. So we'll do moles NH3 to moles of our desired compound. Well, we're trying to learn about N2 or nitrogen. And so we'll look at the coefficients in the balanced equation. There's an implied 1 in front of nitrogen, and there's a 2 in front of NH3. So those are coefficients. So we did molar mass, coefficients. Now let's do molar mass. Moles of N2 to grams of N2. Well, for N2, I just need, the molar mass of 2 nitrogens. 2 times 14.01 will be 28.02. Grams of nitrogen are in every mole, grams per mole. So I'll do 28.02 grams of nitrogen are in every 1 mole of nitrogen. And then that math on my calculator is just 9.05. I'm just multiplying fractions times 28.02. And then in my denominator, multiplying fractions, 17.03 times 2. I'm kind of ignoring all the ones because multiplying by 1's not changing anything. And when I go ahead and do that math in my calculator, I should get 7.45 grams of N2 are my remaining unit. So now, oh my goodness, I did the same thing. Twice I've gotten these lines and I might have to live with it. I just got 7.45 grams of N2. I just don't have the best way of getting rid of a line like that when I get them. And I just did it for the second time. I think as I'm going to the edge of my screen, I hope you'll forgive me. We're all human. We're all going to make mistakes. So I hope you'll live with mine. It says 4.61 grams of nitrogen are made. Let's read our actually made. Maybe I just really wanted to underline the word actually. No. But, and 7.45 grams are from Stoich. That's how much I made in theory. This is theoretical. This is in theory from the Stoich. Okay, so my percent yield equation is actual over theoretical from the math from Stoich times 100%. Okay, so my actual was I only was able to make 4.61, but the math told me I should have made 7.45 grams of N2. So this is 7.45 grams of N2. My 4.61 is grams of N2. Really encourage you to put those units and make sure they cancel, because sometimes you can catch if you are setting up a percent yield problem incorrectly because the units, grams of the compound, one of the units might not match up, either the grams or the compound. So we've got grams of N2 over grams of N2. We're in good shape. So 4.61 divided by 7.45 times 100%. And when you put all of that in your calculator, I know I'm almost out of room. Suppose I could move me here. When I put all of this in my calculator, I can put an equal sign here in the center a little better. I got 61.9%. Why don't you check and make sure that you also get 61.9% for this problem? Okay, I'll try to redeem myself on this slide and not put any big lines through it. Wish me luck. Okay, we've got one last example here. When 163.5 grams of copper, this is actually copper oxide, are allowed to react with excess carbon in the reaction below, 95.6 grams of copper are obtained. Find the theoretical yield and the percent yield. So when it says 95.6 grams of copper are obtained, read our actually obtained. That is an actual yield right there. It says find the theoretical yield. So that's saying do the Stoich. And then the percent yield from the equation. Okay, so what's our known? 163.5 grams. So we have 163.5 grams of copper oxide, Cu2O. Let's put that over 1. And then we're going to bring down grams, Cu2O, and we're going to get to moles right away using molar mass. So our first step is going to be that molar mass step. We're going to need the molar mass. And I'm going to give that to you. It's actually 143.1 grams per mole. I think we had that earlier in our problem. So I think I'm going to give that to you. I'm pretty sure that it was given in an earlier problem. So, and you can go and calculate that with your table if you want, and you can double check me and see. But I think I'm just going to go with that. So 143.1 grams are in every 1 mole. Okay. Now we're in moles. We did our molar mass. We do our mole to mole conversion next with coefficients. Molar mass is done, coefficients, and last we'll do a molar mass again. Okay, so we need to get from moles to moles, and we are interested in copper and comparing how much copper we have. We have excess carbon, which really means that we can kind of just ignore carbon for now because we have as much of it as we'll ever need, so we just don't need to pay attention to it. Okay, we've got a 2 in front of copper for a coefficient and an implied 1 for Cu2O. Okay, let's cancel those. Let's bring down moles of copper. And finally, we want to get to grams of copper so we can compare and see how much we should have gotten for copper. So we go to the periodic table. We've got a mass on our table of 63.55 grams of copper for every 1 mole. Cancel out moles of copper. We're finally in grams of copper. If you do this math on your calculator, it should be 163.5 times 2 times 63.55. And then you want to divide by 143.1. and I get 145.2 grams of copper. Now this is in theory. In theory is from your STOIC calculations. You know, how much does the math say we should have made theoretically? Percent yield then is actual over theoretical yield times 100%. Okay, so they said what we actually got were 95.6 grams of copper, and I calculated we should have made 145.2 grams of copper here, in theory, from the STOIC. I like double checking that the grams and the grams of copper cancel out. It's a great double check. That's a place where students often can catch that they have made a mistake. Multiply by 100 to get that decimal form into percent form. And when you do all that, let's move me so we have room for our answer. I got 65.8% for our final percent yield. So now you should be able to calculate a theoretical yield using stoichiometry and compare that to an actual yield in a percent yield equation.